Tiger Woods Did Nothing Wrong group, and we'll be talking today about our design project for Warman competition 2015. My name is Ali. I was responsible for the programming part, researching all the electronic components and testing stage mainly.
Hi, my name is Cedric. I was in charge of controlling the budget and maintaining the purchases which were made. I was also in the team for producing the chassis, and also I was there for the rapid prototype production.
My name's Scott. In an early stage I was doing CAD modelling and refining of the design, and then later on tuning and editing components of the vehicle, and a bit more testing in the programming phase.
My name's Grant. I was responsible for sensor research and circuit building, as well as helping with writing code and checking.
Hi, my name is Peter. I was in charge of the material selection and sourcing. My main role was documentation and the refinement report and just management of that. During our early stages, we had regular group meetings. Every idea was considered. We all had a turn to talk about what we all wanted. No idea was criticised as it led to our final design. Two main ideas included the vehicle dropping the arms left and right. Another one was the vehicle turning left and right and with a pickup with the fork.
For our concept phase, we all had differing and multiple ideas. Mutual agreements on certain ways we wanted the concept to progress allowed us to progress forward. Matrix analysis allowed us to list out all our different options. And the concept we went with the forks coming down and driving around as opposed to the arm model gave us higher level accuracy, we thought, and more flexibility in design and component selection.
Taking our design from the concept stage into realising the design, into the design stage, we used CAD software, the SolidWorks, to start finding out dimensions and how it's all going to fit together. Things like we figured out in the design stage angles of what the forks were going to look like, maybe some distances, how big the final square, and where the wheels were going to fit. And from here we started finding a more detailed design.
In the production phase of the design process, we discovered design flaws which were overlooked or not considered during the designing of the vehicle. To incorporate things like that, we raised the servos to improve the effectiveness of the pickup function, as when designed they were too low. We also considered a variety of materials, and through producing and fabricating the vehicle we decided which was practical and which was not, which was overlooked during the designing.
The next stage in our design process was the testing stage. We've chosen the open loop programming, and with that comes more responsibility towards making sure that our design works. So what we used, first problem we faced was that getting the vehicle to drive in a straight line where the two wheels are driving at the same speed. So for that we followed, we documented all of our runs in order to find the trend line of our vehicle, the way it's going. And based on that, we made many predictions of the best speeds that we can run our vehicle on. For Warman 2015 project, we were required to design a system that fits in 400mm cube envelope that starts with a single push button, a single action, and is less than 6 kilograms in mass. Also, the runtime should be less than 120 seconds, and the system should not use the edges, overhang the edges. Also, it should be in contact with the floor at all times. So our system is required to drive, start, drive, pick up balls, control the balls, and deposit the balls in the holes.
So throughout the design and production process, we made many alterations and modifications to the design and to the actual vehicle. This was the initial CAD design that we formulated. Most of the measurements that we made stayed fairly similar, or the same, and spacings and the components all stayed fairly similar. Some things that did change. A big major element was the pickup forks.
The main changes on the fork were that we changed it to 6. We've added a second set of aluminium coat hanger just for that extra strength. We measured out the tracks and we aligned each arm to fit into the T.
Alright, here's the exploded view of the model, where we can better see some of the components. We had micro servos initially installed, but we had to change them out, as we'll see how we do that later. Some things like this we didn't in detail go into how we were fixing the motors, but we sorted that out. And this is how the design was coming along midway through the production process. Things that we can see how the high torque motors were installed here. The wheels we had to push into the chassis, so we had enough room and didn't go over the edge. And this is how we installed the, with bent steel brackets, we installed the DC motors, just straight bolted down onto the chassis.
We added aluminium plates onto the middle of the arms just for that rigidity.
One of the changes that we made, this was the final design. We had to cut corners off the back of the chassis so it wouldn't go over the edge of the track.
We added a second set of aluminium and we also added them on the sides just for the direction of the golf balls. We added tape into the middle because they were falling off and going to the next arm. We angled the tips so you allow tolerances against the wall, and
So one of the main issues we had with our vehicle was it not driving straight. So what caused this? So the two DC motors were going at different speeds, possibly due to varying voltages and inconsistency in the motors. So how did we aim at solving that? So we tried to solve that with voltage regulators. We actually tried to log all the data of the different speeds to gauge how consistent they were and whether they were going left and right. And we tried to use this to get the best speeds for each motor, to make it go straight on a most consistent basis.
Another key project issue which we encountered was fork rigidity and weight. What was the problem? Well, the problems were too flexible and that provided difficulty when picking up the balls. Also, the problems were too heavy for the original design and the servos were struggling to do the movement necessary to pick up the balls. What caused it? Well, mainly there was too much material on the prongs. This was too heavy for the servos, thus causing it to be unable to pick up the balls. Also, the attachments which we placed on top of the prong was far too far away from the center of the attachment, and that caused the torque to be far too large for the prong. We solved this by increasing the rigidity of the prongs. We did this through adding a variety of materials such as aluminium sheets and also duct tape to increase the strength of the prongs. Also, to increase the strength of the servos, we put new servos in. These are the high torque servos instead of using micro servos, which increase the power of the fork. Also, by taking off the attachments and putting them closer to the center of the fork, we were able to decrease the torque and moment which was required to lift up the prongs and balls.
Nice.
In conclusion, we've learned so many lessons doing this project. There's so many things that we could have changed if we got a chance to. One of the things we could have used a closed loop feedback. That would have helped us in maintaining the consistency of our runs, and our system would have run perfectly on the competition day, and we would have avoided any failures.
We also learned the importance of taking time through the design process, and also how crucial it is to find every detail of the design so we can analyze what could possibly go wrong. Through doing this, we would eliminate any problems when they arise rather than tackling them when they occur through the fabrication process. This ultimately would have led to a better design.
Yep. We also, despite having quite varied timetables, we did manage to sneak in a few hours a week, and we met our expectations on how much effort and time we were planning to put into the project. We did, however, not plan ahead as to what we were doing at each group meeting, which is something we would need to rectify if we were to do the project again.
This project has been very beneficial for us because we all got to work as a team. We all have our strengths and weaknesses. I personally gained skills in electronics and programming. I had no idea being a mech student, and I also got to use a bit of using power tools.
Alright, wrapping up, we encountered multiple problems through the course of this project, but we've learnt a lot through trying to tackle these problems and what we could have done better. But we're very proud of the final vehicle that we put up, despite having some errors with consistency on the day.